Good evening, hello, and welcome again to my channel, Jaila Bamba. This is Jamila Orior, and inviting you to accompany me on further study in the book, Drugged, the Culture and Science Behind Psychotropic Drugs. Um, the chapter I started talking about was chapter 8, and it talks about psychostimulants, the one with minor effects that we have included in our daily lives, such as coffee, chocolate, tea, and to the most dangerous and the ones with dire effects on our bodies. Um, we also have seen how pharmacology got its hand there and tried to use what it could to and put it to the benefits of humankind and the treatment of certain disorders. For example, caffeine and even amphetamine have been searched for their potential, therapeutic potential for the treatment of ADHD and for the treatment of Alzheimer's disease. And there were some medications that were over the counter and there still are, such as Excedrin, for example, that has both caffeine and acetaminophen in it, and it's a cough syrup. And we have seen how even the most dangerous one have been on pharmacies shelves for people to grab with no prescription and for claimed benefits. And sometimes those claimed benefits were actually real benefits, such as bronchodilation that some amphetamines helps and with. And we are going to talk today. We're going to talk to continue our talk, and we'll talk about their mechanism of action. We've already seen that with some of them, but now we are going to talk about biogenic amines and their role and psychostimulants. Amphetamine and cocaine have a similar mechanism of action. They act on biogenic amine and neurotransmitters. So it is the same mechanism of action for hallucinogen, antidepressant, and antipsychotics. Once released and their action is completed, they are reuptaken by their respective transport molecules to nerve terminals. Many antidepressants block the reuptake of serotonin or 5-HT, norepinephrine, and dopamine. They block the reuptake of these biogenic amines to their nerve terminals. Cocaine acts in a similar way. It can block all three biogenic amines reuptake, increases their concentration in these synapses and their effect on the PNS and CNS. Now, amphetamine acts on the reuptake transport proteins for the three biogenic amines in a different way. It does not block the reuptake, it binds to them the same way, similar to biogenic amines. It just binds to those receptors. It does not block the receptor of the biogenic amine. It competes with them about the receptors and binds to the receptors, causing a release of biogenic amines in the synapses and increasing therefore their concentration and effect on the CNS and PNS the same way cocaine does. So that's what it does. So, and that's what causes all those effects amphetamine causes. And now this is it, and By the end, I'm going to talk about how amphetamine, as we have seen, has been used in pharmacology. Like they created analogs and synthesized analogs of amphetamine, and those were used to treat attention deficit hyperactivity disorder. And there were some parents, lots of parents actually lobbied against the use of Ritalin because it had a really very dire effects on kids' if, life and psychology. It obviously helped them with the focus and increase in concentration, and but it did not help with other things because it just makes them more jittery. It causes it also has effects on the cardiovascular system, and it causes depression and lots of adolescents. Some of them committed suicide because they were so depressed. Now, let's talk about the last section in here. It's the Indian go up in smoke. And it is talking about cigarettes. This is another psychostimulant. Not the cigarettes itself, but what is used in the tobacco and the nicotine, and that's what we are going to go through in this section. When Columbus and his crew got to the New World, again, this is what the New World has to offer, and it's actually what the people focused on. So when Columbus and his crew got to the New World, they observed Indians drinking smoke. They did not say smoking, because they saw them like inhaling, and then they thought it's almost like if they were drinking it. Drinking smoke, they rolled dried leaves, lit them up, and inhaled. They also used those leaves as snuff after grinding them. They called the leaves tobacco, the name that stuck until today. Smoking tobacco among those people was shamanic for religious purposes. It was therapeutic. It helped them relax and, helped them with being energized and recreational. The Europeans who traveled back and forth between the two worlds on the new habit took to the new habit of smoking. It soon reached Europe, and the credit goes to Rodrigo Jerez, Rodrigo de Jerez, who was imprisoned by the Inquisition for smoking in Madrid. They thought a man who inhaled and exhaled smoke through his nose and thought could only be a partisan of the devil, to paraphrase the author. As usual, many therapeutic merits were attributed to the new drug. It fitted well within the Galenic humoral doctrine. It was hot and moist, so it could thus fix conditions classified as cold and dry. It then was added to the new treasures reaped from the New World. It started to be seen as something good and therapeutic. King James saw through it and published a book about how unhygienic smoking was. And the book was The Contrablast of Tobacco, or The Contrablast of Tobacco. He considered smoking as a filthy habit with no therapeutic merit, but a simple act of vanity and imitation of foreigners. Now, see, like how in the third world people would criticize other people, say, "Oh, you're just imitating foreigners and people from the Occident or something." But back then, when people started smoking, a king himself accused the people who were smoking as just, it's an act of vanity and imitating foreigners and infatuation with the foreigners. On the other hand, the French diplomat Jean Nicot, 16th century, brought the smoking habit from Lisbon to France, he was impressed with its therapeutic properties. He acclaimed he used tobacco to cure the Queen's migraine. Nicotine got its name from Nicot's name. So, from experience, actually, um, tobacco does not cure migraine. It's just when you first take that cigarette, and let's say you had a migraine because you wanted to smoke, and then you smoke, and then it relieves that headache, and then a few minutes later or an hour later you have the same headache, and you have to get one, and then you have to get another, and that's how it is addictive, because you grow tolerance, and then one does not do the effects anymore, so you add another one. The other one does not do effects anymore, you add another one, and then from smoking 3 cigarettes a day, you start smoking 10, and then a whole packet, and then probably 2, etc., till you become yourself an ashtray. So it's just really, I agree with whatever that king was. On the other hand, we say that Jean Nicot, who was a diplomat, brought the habit from Lisbon to France, and then claimed that he cured the migraines, the Queen's migraine. He probably just got her hooked on cigarettes. Nicotine got its name from Nicot name, from that person's name. The tobacco plant, scientifically labeled as Nicotiana, has a variety of genera. The genus Nicotiana rustica, encountered in North America, and Nicotiana or Nicotiana tobacco, found in South America, believed to be better, the last believed to be better, and you know how people like praise and have qualify, for example, cigars from Colombia or something as higher quality, you know, and the best, you know, believed to be better. It was the tobacco from South America was brought to Carolinas and Virginia, and was used to produce tobacco. And there were lots of plantations in USA for tobacco. I assume they still are. That used lots of workers, mainly slave labor. The tobacco smoking habit became a global phenomenon. Modern cigarette introduction and worldwide aggressive advertising campaign placed tobacco production among the top industries. Awareness of its health risks and health consideration have curtailed its use. Now let's say, and that's a really a very good move. There's no public smoking. You could get fined, for example, if you take a cigarette and light it on a train or on a bus or in buildings where they say it's forbidden to smoke. So that helps reduce that habit. And then let's talk about the nicotine pleasure and poison. So nicotine is the active chemical in tobacco. So it's not that what you get in the cigarette is like a very minimal and negligible amount of the real nicotine. You get like 0.3% to 0.5% of that alkaloid that is contained in a cigarette and might produce desired effect for you. But pure nicotine is toxic. In both animals, they are using it as insecticide to kill insects, and in humans. And nicotine was the oldest and first substance that helped neurobiology develop a new concept of neurotransmission. John Langley, a professor at Cambridge University, found out while researching the effects of certain drugs on the PNS that such drugs produce their effects by activating receptor substances. And we have seen this in chapter 2. Paul Ulrich in Germany came to the same conclusion. Henry Dale, who was a student of Ulrich, was the one who identified acetylcholine. Those were the first neurotransmitters to be identified and believed it acted as a neurotransmitter in the PNS, acetylcholine. He had the Nobel Prize for his scientific contribution. Otto Loewi, a Nobel Prize laureate, proved that sometimes nicotine produced similar effects to those of acetylcholine in some tissue, while muscarine did so in some other tissue. These substances mimic acetylcholine action, but each acts on a certain type of tissue. He concluded that acetylcholine must have two different receptors, nicotinic and muscarinic. Nicotinic receptors were more focused in synaptic areas such as cholinergic synapses in the autonomous ganglia and junction neurons and skeletal muscles. The cholinergic receptors were the first to be identified in biochemistry and helped the field understand the molecular function of receptors. Electrophysiology studies revealed the nicotinic receptors are ligand-gated. The nicotine receptor is a long, complex protein chain that has 4 subunits that are closely related to there are 2 alpha chains, 1 beta chain, a gamma chain, and a sigma chain arranged as pentameter. The amino sequence of each unit has been identified, and it has been also revealed that alpha and beta units can arrange and rearrange themselves in synapses and can therefore produce variations in nicotinic receptors in synapses. Nicotine effects affect memory, concentration, arousal, and alertness in a desirable way, but affects cardiovascular and gut in an undesirable way. So, as a psychostimulant, it also causes addiction. So, it does act on the same nicotinic receptors subunits to produce the desirable and the undesirable, or is there effects, or is there some selectivity involved? There are many disorders that affect cognition, such as the neurodegenerative disorder, Alzheimer, which is the result of accumulation of proteins in the brain that cause neuron death. It is a very, very scary disorder that can happen to people, and it affects neurons in the cortex, hippocampus, cholinergic neurons in nucleus basalis of Menard that affect the cortex degeneration. Pharmaceutical companies are searching for nicotinic agonists with a therapeutic outcome for AD. So they're using the pure nicotine. They're trying to see if they can find a nicotinic agonist that increases the effect of those receptors and then increases concentration, focus, enhances person cognition, and delays or controls the disorder, or if they could even reverse it. So could they, you have to understand the disorder itself, and you understand also what's affected in the brain to be able to do so, and to find the right agent that could do so. Nicotine, caffeine, even amphetamine when manipulated to just target certain receptors, should their receptors uh, have certain selectivity? Should they target a certain part of the receptor and not another, and to trigger the effects on their to trigger the and enhance the effects that we want to happen, not the ones we don't want to happen. Let's say you don't want to turn people instead. Okay, we're controlling the Alzheimer's disease, but then you see them like all not there because they have been let's say almost hallucinating or something because of the effects. So, or you don't want to see them depressed too much because you have those highs and those lows. So, besides the disease itself is, as I said, the way it happens, it is like deposits of certain proteins in the neurons, and that causes the degeneration and the death, and that causes all those things that happens to those people, and that affects their brain. So other psychostimulants such as caffeine and adenosine receptors, agonists and antagonists, have good effects with less addictive potentials. So they have also been researched for potential therapy for Alzheimer's disease. And my comments here is what I said, like you have to understand the disease itself. So far, when I looked I looked trying to see what's there for this therapy for Alzheimer's disease, and what they're targeting is there. As I put a question in the Google search, are there treatments or therapies for Alzheimer's that aim at clearing or removing the protein deposit in neurons, because that could be the only way that you can cure the disease. I mean, you can give them caffeine-based therapies, or nicotinic, or therapies, or even amphetamine ones that you have worked on in a certain way that they give just the desirable effect. You can increase their concentration, but that's at the beginning of disorder, and then you can control it for a while. You see them still healthy, you can still communicate with them, they are still there, they are still able to comprehend you, talk to you, but those proteins are still there. So even with the therapies that are currently there, there are only the ones that can control it, or the ones they try to break the target certain enzymes, so they wouldn't cause that kind of problem, like for example ALS or something. But for Alzheimer's disease, when I put that question, I had this answer: yes, there are both approved and experimental treatments aimed at clearing or removing the protein deposits, many amyloid beta plaques that accumulate in Alzheimer's disease. Approved monoclonal antibody therapies. The most direct current treatment are amyloid targeting monoclonal antibodies such as lecanemab or donanemab. These drugs enter the brain and bind to amyloid beta protein, marking it for removal by the body's immune system. This process involves microglia engulfing and clearing the bound amyloid, leading to a measurable plaque reduction in early stage patients. So they can do it only at the early stages. So that means they can just it's also just for controlling it, although it clears that it can delay the exacerbation of this because it's a progressive one. Now, lecanemab binds to soluble toxic protofibril of amyloid beta. Donanemab targets a specific form of amyloid called pyroglutamate amyloid beta. These therapies are approved for patients. When they say approved, I'm not sure, do they say FDA or is it like worldwide? They're approved for patients with Alzheimer's or mild cognitive impairment who have confirmed amyloid pathology. So that's what I believe. You have to understand the the disorder completely, because here you have to see is if the disorder is caused by these kind of pathology, amyloid pathology, they say here. But this, they say, carry the risk for having the brain swell or, hemorrhaging and microbleeds. Now, experimental cellular immunotherapy researchers at Washington University in St. Louis have developed a certain bioengineered astrocyte to act as plaque cleaners. So this is, if you see, that's why when I was like, when the author said in the book that's they're trying to use these psychostimulants for the betterment, for the improvement of of controlling the disorders or curing disorder. I said you can control it possibly at the first stages, but it would be hard to cure it just by enhancing cognition, because the what causes the disorder, from what we have seen, what we have learned in medical books and in all kinds of science books, is that because it's caused with the protein deposits in the neurons. The neurons are very fragile structures and very, So I say, even if, for example, a person who has cholesterol or hypercholesterolemia, and then they form plaques, right? You can give them things that, for example, blood thinners or anticoagulants, but those wouldn't do anything. They would just help with the blood be like, flow better. But still, if it's clogged, the only thing that you could do is just bust that clot or remove it. And then you give them the therapy to control their cholesterol. So I said, those plaques has to be removed. And then as I was looking, they said, yeah, those here, they could do the same thing, because you have high density lipoprotein and low density lipoprotein, and you have the high density lipoproteins that act as the good agent in your blood and clears the low density lipoprotein from the blood, so that these things do not accumulate all those debris that the blood collects from here and there. Should not, those they removed, especially the fatty things. So if they could have the same thing, and that's what they say here, something they called as idol, and I think what they meant, what they say is induced degrader enzyme, low density lipoprotein. So it's basically also it's a proteins that you need to remove. They are the bad proteins that accumulate in there because of certain things that went bad at the cellular level. So yeah, if they could find that would help, because people, although they have cholesterol, they continue to live, and once they they, they do not have plaques that actually block the vessels, because when they have these, they have to remove them. They do not just give them statins to control it, they have to remove it, because otherwise they have strokes, they have all kinds of horrors. So, uh, if you have any ideas on the issue, please comment, and then tell me if you have better insight, or you have any insight at all, and then we could communicate. I'll answer to your comments to the limits of my knowledge. And then I advise you to read the book itself, or go through similar topics. And then if you want to comment on this section, go to the previous presentation and also have a look at it. Okay, I wanna be able to present more and apply myself to presenting more frequently, and have better structure in going up there and talking to you and presenting material to you. And I can do that real good, but I see that encouragement from anybody. But I know there are other people who are interested in similar topics. And if you are, and by any chance you click on this and you listen to me once or twice, yeah, subscribe. And post your comments. If you have a channel yourself, just invite me to yours and let me see what you have, and then I'll also subscribe. Okay, have a good night, and see you on another day. Bye bye.